Hello. Today we're going to talk about topic 3, section 3, triangle applications. All right, so triangle apps or applications are basically just word problems. Okay, so real life examples using trigonometry. Okay, so this image is dating back this far. Okay, guys, this is a Sea Island survey diagram. And when you do surveys, you're basically trying to figure out distances. Okay, so if we're standing over here, we can estimate how far away something is or how high. So, anyway, so the first thing we need to be able to do is solve a triangle problem. Okay, so if you're given this information, can you visualize the problem? Okay, so label and draw. Try and figure out your triangle pieces. Okay, so hopefully you drew something like this. Okay, and now we want to find the area of the triangle. Okay, so Cognitive does it one way. Okay, using the law of cosines. All right, we can figure something out. All right, I think I'm going to do it a little bit differently though, because if you use the law of cosines, you end up with a quadratic, and quadratics can be gross, right? Because not all of us have that poly simulation app, so then you have to graph it and find the x-intercepts and do all that stuff, okay? So what I'm going to do is I'm going to use the law of sines instead. So I'm going to try and figure out this angle. So I know the sine of theta over 4.2 must equal the sine of 65.6 over 6.5. All right, so then I'm just basically going to be using my calculator, right? Move the 4.2 over, then take the arc sine. So our angle should be, here, let me get out the calculator. So we're going to do sine of 65.6 divided by 6.5. And, oh, am I in the right mode? Yes, I'm in degrees. Okay, so let's make sure we're showing our work, actually, because I don't think, you guys don't do this all the time, so let's make sure. So we're going to get sine of theta equals 4.2 times all of this. Well, we can just put the abbreviated, as long as our calculator has the exact one. So that was 0.1401. Okay, 3 dots. All right, so then we do 4.2 times that answer. So 4.2 times second negative sign. Okay, so now we get 0.5884. So now we're going to take the inverse sine of that. So the inverse sine of 5884 and a lot of stuff. Then we do second sine of our answer, and we get 36.046, blah, blah. Okay. Well, if we do it, let's see, 340465 dot, dot, dot. And then, so that way we don't get marked off for rounding. If we put all that, then if I said like 3 sig figs for the theta, oh, well, it's, just kidding, it's not even asking for the angle, it's asking for the area. So our angle rounded to 3 sig figs would be 34.0 degrees, okay? But we're not looking for just the angle, we want the area. Well, the area of a triangle, we can do 1/2 AB sine of C. So we need 2 side lengths and the angle between them. Well, we have this side length and this side length. So let's use this angle. Okay, so if I call that, well, I don't know why I called that A. Let's call it little b. Okay, so angle B here. Why am I using little b? We have a B right here. Okay, so angle B is the one we're going to use. So for this triangle, it would be 1/2 times 6.5 times 4.2 times our angle B. Well, I'm sorry, sine of B. Well, we just found out this angle. So to get this angle, all right, B would just be 180 minus theta minus 65.6. So luckily it's still in our calculator. So we're going to do 180 minus our answer minus 65.6. And we get 78.35. Okay, so 78.35 approximately degrees is the angle there. So we plug that in here. So we do 1/2 times 6.5 times 4.2 times sine of 78.35. Again, I'm going to leave it exact. So 0.5 times 6.5 times 4.2 times sine of our angle, which was our previous answer. We get 13.36896. 6896. Ooh, had to remember it all. Okay, so our area ends up being this. So let's see, calculate the area of the triangle. I cut off the part. It should be to 3 sig figs, so 13.4 square centimeters. Okay. Let's see, one of the biggest problems I see when it comes to labeling things when kids have to draw their own figures is they mess up labeling the angles. So notice I go from B to C to A. Okay, so draw your line as from B to C to A, and notice this is the angle I covered, right? If I go from A to B to C, that's here to here. Whoa, A to B. Oh, what am I doing? A to B to C. Okay, so it would be this angle. Okay, so watch how you're labeling it. Okay, I see a lot of kids go, oh, A, B, C, and then they start talking about this angle or this angle. No, no, no. B was in the middle, so B is where the vertex is. All right, so here we have example 2. We are given this information about a quadrilateral, so you want to be able to draw it. So take a chance, see what you can do. Pause this and try. Okay, hopefully you drew this or something like this figure. Okay, so we get this figure and we want to find the area. Okay, well, we don't have a formula for some weird looking quadrilateral. Okay, we have formulas for trapezoids and squares and rectangles and a rhombus and a kite and all these other things, but not this weird one. So what do? Well, what I would do is I would draw a line right here. If you draw a line right here, we now get 2 triangles. So we have triangle 1 and triangle 2. Okay, so the area of the quadrilateral ABC, or ABCD, is triangle ABD plus triangle DBC. So these 2 triangles together. Okay, triangle 1 plus triangle 2. So let's do triangle 1 to get us started. Okay, so I'll do that one in blue. So what we do here, well, the area of a triangle is just 1/2 base times height. So we do 1/2 times 40 times 30, and we should get 600 square centimeters. Now we do triangle 2. So for this one, okay, it would probably be easier to do 1/2 AB sine C. So in this case, we have this length and this length, so we need this angle. Okay, so we're going to be doing 1/2 times 71 times 50 times sine of whatever that angle is. So we got to find it. I'd probably use, let's see. Well, we could do the law of cosines if we had this one, and we can find this piece right here. So if I call that x, well, you can use the Pythagorean theorem. 30 squared plus 40 squared equals x squared. So let's see, what is that? 900 plus 1600, so you get 2500 equals x squared. So x should be 50. So for here, to figure out what c is, we can do the law of cosines. So that would be 50 squared, let's see, equals 50 squared plus 71 squared minus 2 times 50 times 71 times sine of angle theta, or angle C. Okay, so we work all this out on our calculator, right? So you square these, subtract them, then divide by this, and then take arc sine. So let's see, you should end up with what? Negative 71 squared divided by negative 2 times 50 times 71 equals sine theta. So to get theta on your calculator, you're going to have to do the arc sine of all this stuff, which ends up being 71 over 100. I'm just making it a little shorter to plug into my calculator. So second sine 0.71. So 45.23. All right, 45.23. All right, now we have our angle, so now we can just plug that in up here. So we do the sine of that angle times 1/2 times 71 times 50. And where's my calculator? Okay, so 0.5 times 71 times 50 times sine of our previous answer, and we get 1260.25. So 1260.25 square centimeters, and we add 600 to that. So our final answer is this one plus this one. So we end up with 1860.25 square centimeters, because this is area. All right. And, oh, sorry, give your answer correct to 1 decimal place. Okay, so one decimal place would be the 10th. Wait, hold on. Okay, I hope you finished watching the video and you saw my mistake, because I sat there and said law of cosines how many times? Yep, but I wrote sine because I was doing that with area. I don't know what's going on. Silly me. Okay, so hopefully you hadn't sent me a remind message yet. If you did, it's all right. But I fixed it here. So that should have been cosine, inverse cosine. So my bad. Let me fix that, which then changes this answer. Oh my gosh, it's just like this long spiral effect. Okay, so we should have done cosine. Let me just start all over, clear everything. So we needed to do the inverse cosine of 0.71, and that gets us 44.765. 44.765. Then we do that into our area, so 0.5 times 71. I still can't believe I just did that. Okay, times sine of the angle. 1249.95. Yeah. 1249.95 dot dot dot. I think that's what it said. Okay, so we want to do one decimal place. That would be the 10th place. So if we are rounding to the 10th, okay, so the final answer should be 1849.957 dot dot dot, but we rounded to the 10th place, the first decimal. So that means that needs to go up. Well, that rounds the next one, which rounds the next one, so it ends up being 1850.0. Yes, you put the 0.0, okay? But that would be it. Okay? Okay, so I touched base on a little bit on what surveying was, but another term you've got is triangulation. So we're using triangles to find the distance of how far away something is. So let's say I'm standing right here, and I have this path, this road, and I notice something far off in the distance, right? I can measure this angle, and then I take a walk down the road some meters, and I go down to B, and I still look at that figure over there, okay, or that object, and I've got another angle. Well, now I know how far I've traveled and my two angles, and that's all I need to find out the rest of the pieces of the triangle. So how far away is that object? Okay, so here we have another example. It's all about visualization, okay? So this is going back to 16th century, okay? It's been going on forever, okay? Well, you may not be doing this in your day-to-day life, but it helps you, right? If we didn't do triangulation, then we couldn't figure out how far things are and how to build and all this good stuff. Okay, so we have our triangle, and I know it's a little bit hard to see, but here is angle D. I think that's B, and A and C. That's a little hard for me to read. Okay, so, okay, I think this is DA. Yeah, the base of DA, so basis. This is 10, and the angle A is 90, so this is 90. And what's the width? Oh, I'm sorry, angle D is also 82. Okay, so it wants to know the width of the river, the Seine River. So what we can do is, are we looking for the hypotenuse or this distance? Okay, so what would be a better approximation for the width? Okay, well, think about with your triangle. What's going to be the biggest side in a triangle? Your hypotenuse. In a right triangle, I'm sorry. In a right triangle, the biggest side would be the hypotenuse because it's across from 90. Well, if you're going across the river, do you want to go across the longest distance? Well, I wouldn't. All right, get me over there and get it done quick. So let's find this distance. Okay, so you're applying logic, okay, and trying to figure out which number to solve for. Okay, that's what's different about applications, all right, word problems. It doesn't tell you always specifically where it is. You have to apply knowledge. So now we've got a triangle, so maybe it might be easier to see it redrawn. So we have this, base is 10, 82 degrees. We're finding this distance. So hopefully you noticed we can use SOHCAHTOA here. So tangent of 82 is x over 10. So we do 10 times the tangent of 82 to get x. And we get x is approximately 71.15. We round to the nearest meter. So that's going to be 71 meters. Okay? Okay, so here we have another example. Okay, so I know, you read through it, it might seem a little overwhelming, but they provided a visual here which really helps. So A is where the land surveyor is starting, okay? So B is your distant tree, so here is your tree, okay? Beautiful tree. All right, then we start walking along this path, and then she stops here and she measures the angle between this tree and the second landmark. So the other landmark. I don't know. Is it another tree? Is that what she said? It just says both of the landmarks. Okay. So then she keeps walking along another. All right, she changes her angle here. It's now 49 degrees. And she starts walking along here, and then she stops here. Okay, so she started here, she walked along this trail, and ended here. So we want to find the distance between two landmarks, B and D. That's what's labeled X. So really it's kind of nice because you've got 3 triangles here. It's just a matter of finding the right stuff. So look in this triangle. Well, we want to find X. We could probably use the law of cosines if we had our 2 pieces. If we had this side, okay, and if we had this side. So let's find them. We can figure it out using our triangle knowledge. Okay, now here for this triangle, we can just use the law of sines, right? Let's see. Well, first we need to find this angle, right? Do 180 minus 67 minus 36. Okay. Ooh, sorry, looking at the wrong thing. All right, so this is 77 degrees. So we know sine of 77 over 5 is equal to sine of 67 over y. We'll just call this y, since we already have an x. Okay, so we want to figure out what y is. So here we can, let's see, if we multiply this one by y, we get, ooh, I'm not writing that correctly. So y times sine of 77 over 5 equals sine of 67. Or you could cross multiply. You could do I guess cross multiplying probably would make it a lot easier to write. Okay, so if we do y times sine of 77 equals 5 times sine of 67, you get the y by itself. It's over sine 77. So that's what y is. Okay, some gross decimal. Then to figure out what z is over here, well, we could do the same thing. All right, we could use our law of sines. Okay, so let's see, angle D would be 101 degrees. So then here I would have sine of 101 over 6 equals sine of 30 over z. So z times sine of 101, if I can write that nicer, 6 sine 30. So z is just 6 sine 30 over sine 101. Okay? Okay, so we've got problems because we want to use these numbers in our next calculation, but we don't want to use the rounded answer. So we've got to figure out how to handle that. Well, we can use our calculator. So I labeled this as y, so I'm going to go over here and plug that in. So we do 5 times sine 67. Again, I'm solving for the green one, divided by sine of 77. I want to store that answer. So I'm going to use this STO with an arrow. That stands for store. And I'm going to store it as letter y. So alpha, the green button, press the number 1 because that's where y is. So y is this answer. So anytime I use that letter y, it's that number. Okay, so let's do it again. Let's solve, put z in. So 6 sine 30 divided by sine 101. We're going to take that answer and store it as alpha z. So now we have y and z. So if we go back over here to find our final answer, I guess I don't need that equal sign there. right? To find the blah, 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 the final answer x, okay, we want to use the law of cosines. Okay, so we know that x squared equals y squared plus z squared minus 2yz cosine of 113. So now it's just a matter of plugging that into our calculator. So we take alpha y, square it, then plus alpha, well 2 I guess to get z squared, then minus, oh too soon, minus 2 times alpha y times alpha for z times cosine of 113. And we end up with 429335. Dot, dot, dot. Okay, that's what x squared equals. So then we need to take the square root of our answer. So x is approximately 6.55, what did I say? 236. Okay, so x is that, and it asked for the nearest, find the distance to the nearest kilometer. Okay, so the nearest kilometer would be 7 kilometers. Okay, so notice I did not round anything until my final answer. If you had rounded your y and your z and then used those decimals, you may have gotten a different answer, because see, that's pretty close. What if you had rounded too small and you got, 6.4? Then you wouldn't have rounded. Okay, you could have gotten 6.49 and you still wouldn't have rounded up. So just be careful, okay, when you're solving these. Okay, learn your calculator and learn how to store those answers. Okay, so let's talk about bearings. When when you watch movies or you see people talking, they're like, oh, I just lost my bearings. That's, I lost my direction. I can't tell where north and south is anymore. Bearings are where things are, okay? And so when you say you've lost your bearings, you're confused, okay? You don't know where you're headed. So the angle, or bearing, more specific, is the angle between your north line and where you're at. And you're always reading it like a clock, okay? So you're starting here at 0 degrees, and instead of going to 1 o'clock, 2 o'clock, 3 o'clock, 4, 5 o'clock, 6 o'clock. Okay, sorry. Instead of going to those, you're going to angles, so 0 degrees, 45 degrees, 90 degrees, 135, 180, right? So these are all just your straight lines cut in half, right? We have our north, east, south, and west. Okay, think of like those, your axes. What I always learned to remember, north, east, south, west, again, people learn different things. If you hadn't learned anything, how I remember it, hopefully this helps you, is never eat soggy waffles. That's how I remember. I don't know why. My sister taught it to me. Older siblings are always weird. So, love them. Please don't take offense to that. She taught me a lot of weird, acronyms. Anyway, so never eat soggy waffles. Whatever, it works. Okay, so let's use an example. So we have a ship. We've got a bearing. Now notice it does look a little weird because it says 040. All right, when you are describing your bearings, you always want to make sure you're accurate. So you always do 3 numbers, right? Because you could go as far as 360 degrees. So you always use 3 digits. And it's important that if the first digit is 0, you use it. Okay, so you say it. It's, I like to think of it as exact, like if you're on a boat and you're telling someone your bearings, if you don't give 3 numbers, then they think the connection was lost. Okay, or there's a glitch or you're messing up. So if you say all 3 numbers, then they know, okay, I've got it all. Okay, so after changing direction, okay, so you leave a port, you travel 40 kilometers on a bearing of 100, or on a bearing of 40 degrees. Then you change direction and you travel another 70 kilometers. So to visualize that, this is what it's going to look like. So you always use your north line to measure your bearing. So we started here. We had a bearing of 40 degrees, and we traveled in that direction. So that direction of 40 degrees. Then we shifted gears. All right, instead of going 40 degrees, we now change it to 120 degrees. So we basically made a right turn and went this direction. Okay, so now we want to find how far I was from my original position. So if I hadn't gone out of the way and had to make a right turn, what if I had just gone from point P, right? How far away is that? Okay, so we need to find certain things about our angles. All right, so for example, it would be useful to know this piece right here, okay, what that angle is, because we can figure that out because we have two parallel lines, because these are north lines. When you have two parallel lines and a transversal, okay, these two angles have to add up to 180. Okay, remember parallel lines. Okay, so parallel lines, you have a transversal, this angle and this angle, so x plus y have to equal 180. Okay, hopefully remember that. Ooh, sorry, I was trying to shift it. Just trying to get it out of the way. Okay, but leave that there in case you guys forgot. So this angle A right here, or this, I don't know, left side of A, needs to be 140 degrees. So that's 140, and this is 120. That's 260, which makes this 90 degrees. What am I saying? I can't count. I can't count. That's 100. Sorry, yeah, I don't know. 100 degrees. So we've got 100 degrees. Now we've got two side lengths. Oh, cool. Check that out. We can do law of cosines. How handy is that? So we've got x squared equals 40 squared plus 70 squared minus 2 times 40 times 70 times cosine of 100. Law of cosines. So we plug that into our calculator, and we should get 86.44. It didn't say, so we'll just default to 3 sig figs, so 86.4 kilometers. Again, I will be clear, okay, on the test. All right, so now we have a second example. All right, we have a ship sailing around an island. Awesome. All right, so they're traveling along this way. We want to find the bearing of C from B. So we're at B, so this is from B, so we're here. Okay, so here's our little ship. Oh yeah, super cute little sailing boat. Totally looks like a sailboat. Okay, that little tiny flag. It's adorable. Oh yeah, super cute. Just needs a little rubber ducky. All right, so from B, how to get to C? Well, you always do your bearings from the north, and then you go clockwise. So we're going clockwise until we hit until we hit the C line. Okay, so we can travel in this direction. So what's this angle? Okay, maybe I shouldn't use theta since they already wrote it. So this angle is your bearing for A. All right, well, we need to figure out what theta is. Hopefully you notice this over here. We have another transversal, two parallel lines, right? They're those interior angles. So this angle is 80 degrees. So if this is 80 and this is 79, this one has to be 201 degrees, right? Because 360 minus 80 minus 79 equals 201. All right, the next one is B. So find the distance of AC. So find X. that's just another law of cosines. Okay, so we're going to have, see if you can set it up, x squared, 30 squared, cosine 79, we get 34.142. Ooh, if I can write. So 3 sig figs, we're going to get 34.1. Kilometers, because it's distance. All right, for this one, we have elevation and depression. So the downward angle from a horizontal line, blah, blah, blah. How I know depression and elevation. Okay, so see this guy standing right here. Imagine, or, just do you, and stick your hand straight out. Okay, when you stick your hand straight out, okay, that's mimicking this line. So if you lower your hand, if you lower it, so now your hand goes down, that's that angle you're covering with your arms flapping down is the angle of depression. Down here, when your hand is outstretched and you rise it up, okay, you lift your hand up from there to go here, that's elevation. So when I have my hand out straight and I rise it, I'm elevating it. When I lower my hand, it makes it sad, it's depressing. All right, so that's your angle of depression. Angle of depression and your angle of elevation are equal. Okay, but you have to know which angles they represent. Okay, it's not this angle and it's not this angle. It's the angle that you wave with your hand. Okay, so just be careful there. So, of course, let's do an example. Take a minute, read this. We're going to work it out. So, we have an angle of elevation. So, his arm is out front and he rises it up to get 81 degrees. Okay? The distance to the tree is 8 meters. And let's see, if his eye level is 1.58 off the ground, okay, we want to find the height of the tree to the nearest centimeter. Okay, so if we work this out, so I'm going to bring this 8 up here, and this 1.58 is the same over here, right, as he is over there. And now I want to find this value. I know some of the tree, but now I want to know the rest of it so I can add it up. So to get that x, I would need to do tangent of 81. So x is tangent of 81. Oh, I should write that nicer. 8 times the tangent of 81. We get out our calculator, we get 50.510, and let's see, that figure plus the 1.58, because if we don't, we're only getting part of the tree. So we have to make sure we add both parts, and we get 52.09. Okay? We round to the nearest centimeter. Wait, was that what it asked for? The nearest centimeter. Oh, okay. So, okay. Sorry, I got myself turned around. That's meters. So in centimeters, you multiply by 100. So that's 5209 centimeters. All right, you're going to round the meter to that 100th place, or write it as centimeters. Okay. So let's see. Since they said to the nearest centimeter, I would probably leave it like that. All right. Our last example is we've got an eagle sitting on top of a tree. Yeah. At the edge of the ocean, watching a fishing boat. Okay. The angle of depression is 24 degrees and the tree is 47 meters tall. So visualize it. See if you guys can draw a picture. Okay, pause it and try. All right, hopefully you get something like this. Okay, so here is my fishing boat. It's down here, and this would be representative of my tree over here. My tree. Yep, it's beautiful. Well, I was getting off the page, but I guess I could. Ooh, I don't know what I was doing there. So this is my tree. Okay, and my eagle is up here. This is going to be interesting. So here's my eagle. Yep, totally looks like an eagle that's sitting on a branch. Drawing's fun. Okay, so here we have the angle of depression is 24, the part that drops down, 47 meters tall. So if that's 24, this is to be 66, right? So 90 degrees. Okay. Then how far is the fishing boat from the eagle? So that would be X. So A is asking for us to find X. So let's find X. We can do that, let's see, by using SOHCAHTOA. So this would be, if we're using angle 66, this is the hypotenuse, and this is the adjacent. So adjacent over hypotenuse would be cosine of 66 is 47 over X. So we end up, all we have to do is do 47 divided by cosine of 66, and we get 115.55 ... Okay, so if we did 3 sig figs, it would be 116 meters. I skipped this step and I just realized maybe some people didn't notice what I did there. So what I did is I first multiplied by X. So I did X times cosine of 66 equals 47. Then I divided by cosine 66 on both sides, and that's how I got that. Just so you guys know what I did there. Sorry about that. I didn't mean to skip a step. All right, B. How far is the fishing boat from the base of the tree? So that would be our Y value. That would be this one down here. So again, using our 66, this is our opposite. This is still our hypotenuse. Just so you guys remember, this was the hypotenuse. This was the adjacent. So for the purple part, we can do sine of 66 is Y over the, I did the hypotenuse, but then I'd have to use that gross decimal. Let's use our adjacent. Okay, so instead of sine, let's use tangent. So Y over 47. So Y is just 47 times tangent of 66. So 105.56 ... to the nearest meter would be 106 meters. Okay. Hopefully that makes sense. All right. If you guys have any questions, please come to me at class. I'm there, willing to answer any questions. I know it's weird doing word problems, okay, applying it to real life and using that logic, you know. That's a big part of math, okay? Got to know how to apply it to the real world. So let me know. I'll be happy to walk you through anything.